Welcome to my channel. Let's see how we can solve this LeetCode problem together. We have a surrounded regions. We're given a 2D board containing X and O's. Captured all regions surrounded by and O's capture all regions surrounded by X. A region is captured by flipping all zeros into X in that surrounded region. So after running your function, the board should be that. So as you can see, this has been flipped, but this is not flipped. And the reason is given that surrender region shouldn't be on the border, which means that any hole on the border of the board are not flipped to an X. So this is retained. Any hole that is not on the border and that is not connected to an O on the border will be flipped to X. So what they're saying is that if you have an O, definitely we know that if an O is on the border, so the border could be the first row or the last row, the first column or the last column. Take note of that. And if you have any hole that is connected to a O on the border, then it will not be flipped. That's what this is saying. But any hole that is not on the border and is not connected to an O on the border will be flipped to an X. So in other words, any O that is connected to an O on the border will now be flipped. And the connection is defined by horizontal and vertical. Okay. So let's see how we can solve this problem. There are various approaches to solve. But one intuitive way to solve the problem is to first of all take care of the border. So we check the border and see if we have an hole in the border. And if we have an hole in the border, we can then use that to explore other holes that are connected to it. So what then we do is that we take the first row, the last row, the first column, the last column. For instance, in this case, we have an hole here. Then we turn this into a different character entirely, and then we now use this to explore whatever is on the left, on the right, on top and beneath of this, such that we turn it, if it is an O, we turn it also to that special character. Once we have been able to do that for all of the sides, then we can just loop through the entire matrix and turn every other O's into an X, and turn every other special character into an O. Okay, so let's see how to code that briefly. So what we do then is we need to get our sizes correct. So our row size will be the length of our board, and our column size will be the length of our board and the first row. So first thing we want to do is to go through the first row. So we can make our first row, we make it constant to be 0. Then we iterate through our column in range of, that is going to be the column size. So the column size. So essentially what we're doing here is we have still put our pointer here. So we're not considering it. Let's assume we're going row by row. So first row, second row, third row, fourth row. So here we have stationed our row to be the first row. Then we are now moving our column by column downward. So we're now going column by column on just the first row. So we take this, we take this, we take this, we take this. So that's what's happening here. So we'll check if the board and on that row and the column, it's equals to what are we looking for, an O. So if it's equals to an O, I think we're using capital letter. So what are we going to do? We will need to what? Change that into a special character and explore on that. Alright, so I will just put a pass there for us to come back to that. So we'll do similar thing for the last row. So we just copy this, and so as you can guess, we need to do that 3 times. So this will be the row size. This is the last row, but because of 0 index base, we have to remove 1 from that. And the next is for us to station our pointer to the first column, where we now move through the rows. So this will be, we station our column to the first column, then we start going this way, this way, this way. You understand that? So we can use the same. So this time around, this will be column, it's on 0, and now we are now moving through the row, and this will be the row size. Okay, then the last one will be when our column is the last column, and that is going to be the column size. Because of 0 indexing, we remove 1. Great. So now the next thing we need to do is to write the common explore function that we go over every neighbor of these holes that are the border, and that will be an essentially a breadth first search or a depth first search. So I can just call this so we can write an helper function for that, and we call it explore. So this will explore neighbors, and what will our explore need? It needs the board, it needs the row, it needs the column. Alright, so the same thing, that's what we're going to need in all of these places too. Okay, so we now write our explore function. So let's now write the explore function, and we can define that function just right above here. So it will be a function inside of a function. We can also define it outside of this function, but it just keep things neat if we put it here. So it's taking the board, it's taking the row, and it's taking the column. Now what do we do with that? So we check if there are 2 ways I'm thinking we could do that. We could just here inside here change this to a special character. But as is normally done in other programs we are written, let's just follow that pattern. So we check our edge cases. So we want to make sure that, so because we need the row size and the column size, it will be better to declare this after the variables are available. So I can check if the board, if the row is, I think I got something nicer than that. We can do 0. We'll correct that. Because let's say this first. So if the row is greater than, the row is less than 0, or the column is less than 0, we're just checking the border, or the row is greater than equals to the row size, or the column is greater than equals to the column size. All right. Or if the board of the row and column, if it is not equals to what do? We just return, we backtrack. But if it is, what we do is we turn the board of row and column, we turn it to a special character, say P. And we will now need to explore all the neighbors. So we keep row constant, check column +1. We need to do this 4 times. So the next is column -1. That is on the horizontal. So we do the vertical now. That will be column +1. That will be the vertical movement. And the last one, column row -1, which will be the down. So down, so up and down. So this captures the sideways, this captures the up and the down. So by doing so, we have been able to turn the board into a special character, and we have used explore to continue. This we do it recursively, turning everything into a P until it actually backtrack, or if it does not see something that is an O. So if any of these conditions holds, then it backtrack and try another one. But to continue to do this until this holds. So that's the depth first search there. Okay, we're almost done. So the last thing now is for us to turn all our holes into AX and all our P's into an O. So the final thing will be for us to run through our entire matrix and say for row in range of the row size, and for column in the range of the column size, and then we check if the board of the row and that of the column, if it's equals and O, we change that board into a P. So we change it into an X, sorry. So if it is not, we just change it else. And if it's the board is equals to a P, we change it to an O. Okay, so let's now walk through our code. This is our intuition idea. We don't know whether it is correct or not, but that's just our idea of what we feel should work. Just like simulating an interview process, we'll need to do a walkthrough so that we'll be sure that we have been able to run our code without any bug. So let's take the examples that they're giving us here. So here the row size will be 4 and the column size will also be 4. So now it will skip this function and it will get here. So here our row is declared as 0 and our column is starting from 0. So column is equal to 0 here. So we check this. If this equals to an O, no. Then column becomes 1, no, no, no. So the whole of this does not do anything. Great. Then we come here. So our row here is equals to 4 minus 1, which is 3. And our column is starting from 0. So we go to the last row, which is this. Then we take our column, which is 0. Is this equals to an O? No. Column becomes 1. Is it equals to an O? Yes. Okay, great. Because it's equals to an O now, what we will see happen is we need to now do explore on this. So we do an explore on that. So it comes in here and it checks our row value to be equals to 3 and our column value to be equals to 0. So what this does is we check out this condition: 3 less than 0, or is 3 greater than or equals to the row size, which is 4. No. Then we check 0 less than 0, or is 0 greater than or equals to, that is false. Is our board not equals to 0? That is false. So it turns this to a P. So this becomes a P. So let me just copy this so that we can see how things move. So we can come in here and see the way our board is changing. So I put our board in here. So our board at this point in time, this turns to a P. So that's the state of our board. So but then it has to explore. So column plus 1 that is uh, the one on the sideways. So it checks this one because column was 0. Excuse me. Let's see what. Oh, row 3, column 0. Excuse me, this will not be. So this will actually be when column is equals to 1, because this is row 3 and this is column 1. So this will be 1 in here, and this is dissatisfied, and it will come in here and change that to a P. And when this becomes a P here, then it will do all of this. It will check column plus 1, which will be 2. So it will check this in front, then it will backtrack because this condition will not be satisfied. Because this condition is satisfied, so it will return. Now it will also do column minus 1, which is this one minus 1, the original one, just you to check before it. So it will also backtrack because this condition is satisfied. Then it will go up, which is the row is 3, so it will be row equals to 4. Okay, that will be going down, so it will go down 4. This condition will be satisfied because 4 will be equals to 4. Then it will go up, which is 3 minus 1, 2. So going up will be this is the 2. So it will backtrack because this condition is satisfied to return. Okay, so we can see that our code works thus so far. Then we continue like that. When it backtrack, it comes back to this place, so this is where we are now. And of course we fix our column at 0 and our row by row, and so we also go through that. So our row also start from 0. So column is this, so this one is not an O, this is not an O, it's not an O, it's not an O, and the whole of this is completed. Then we come in here again, and the column here is equals to 3, and the row here is equals to 0. And so the column is 3 here, so it checks this, it's not an O, it's not an O, it's not an O, it's not an O, then this is completed. And the next thing is it takes this board, this is now the new state of our board, and checks that this now becomes any O's comes to an X and any P comes to an O. So by going through this section of the code, the whole of this one, so this one will be turned into an X, this will be turned into an X, this will be turned into an X, and this will be turned into an O, and that matches the answer. But one quick thing I would like to do is, let's say that originally what we have is that we have this is an O, and this is also an O. So the answer, what do we think the answer will be? Because this is connected, this is the border, so we preserve this, but we can navigate all of this. So the answer will be, all of them will be x, 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 x. These are some of the cases we check, we write out in interview process. So let's walk through that and see how that will work. Intuitively, we expect it to work, but let's just see. So this, I'll run that quick, fast on that. So this will be the same, and we skip that, and we come in here. So columns start from 0, and as you know, it goes column by column, and this is the board we are going through now. So since there's no O here, that is skipped. Then it comes in here, and it goes column by column again on the last row. So this, by the time it gets to column equals to 1 here, so it gets here and the column equals to 1 here, this is where we are in. It matches an O, and then it does the exploration. So by the time it comes here, the row is 3 and the column is 1. And so, because none of this condition is satisfied, as you can check, it will come in here and change this to a P. And it does explore. So it does this for the front, and it says that it's not and O. Because of this condition, like we mentioned earlier, a backtrack. Then it looks sideways before using this condition, then a backtrack. Then it looks down using this condition, because it is equals to the row size now, a backtrack. But when it looks at this condition, it matches an O here. So by the time it comes in here, none of this condition is satisfied, so it doesn't backtrack. Then it comes here and change this to a P. In our subcall of this, because at the point it was making a recursive call, our row has become 2, because it was originally 3. So 3 minus 1 becomes 2. So this is still valid. So we make a recursive call on row 2, and column remains 1. So it continues to move on that column 1 and goes up. So it makes a recursive call again, looking at this. By the time it makes a recursive call, then it has turned this to a P. Then it checks column plus 1, which is what? 2. So at this time it goes to the right. So it moves to the right because the row remains 2 and the column now becomes 2. So it goes to the right on this row 2. So if you are to number the row, you can see this is 0, this is 1, this is 1, this is 2, this is 3. Okay, so if you are to number that, you'll see. So it's going to now, so we are in row 2, and this is column what? This is column 2, 0, 1, 2. So because this satisfies, the time it makes a recursive call based on this, all these are not satisfied, then it turns this to a P. So this becomes a P. Now it makes a recursive call again, as you can guess. So you make a recursive call again on this. By the time you make a recursive call on this becomes 3. So this is the current value of row and column on the stack. And it makes a recursive call on 2 and 3. So by the time it does that, it checks the column is it greater than or equal to now. At this point, it's still on row 2, but the column is 3. So this is satisfied because that is an X. So it returns. And when it does returns, it will return based on the last column, which is 2. And that is what is going to carry in here, as the row here will become 2 and the column here will now be 2 minus 1. So it's on row 2, then it checks for column 1 and it sees that it's already what? This one. It's already a P, so it backtrack. Then it uses the previous row and column, which is 2, and comes in here. And when it comes in here, it will be making a recursive call on 3, 2. So 3 and 2. Now doesn't work, and it backtrack. It's 2, 2. So it makes recursive call on 2, 2. So by the time it comes in here, this becomes a 1, and this becomes a 2. So it does that, and it takes row 1, and the column is 0, 1, 2. So here, none of this condition is satisfied. So it turns this to a P. And it continues like that, as you can guess, until all of this is. Alright, let's run it and see what it gives us. It's just a line. Yeah, we have some error there. Let's check what our error. We're almost done. We're having a P and an O. So let's check the cases. Is this small letter or capital letter? So it's getting. I hope we're using an O and not a 1. Not that. Yeah. Yeah. It's different from this. Yeah, it's different from this. We should be right. And we're using a capital letter. Oh, sorry, we should do an assignment here. That's where we have it. That should be an assignment, not a comparison. Okay, so let's run the whole code. We still have another challenge. Okay, that's an edge case. We need to check that. So what do? If we can just check our edge cases. If not bought, we just return the board. That's an edge case we need to watch out for. So that works. So I hope you benefited from this. Thank you very much, and see you in the next one.